Class, we will start today's lecture with a recap of the periodic table. So this is how your periodic table looks like. If you remember yesterday's lesson, we have here the zigzag border, which separates the non-metals from the metals. So let me repeat that. You have the zigzag border, which separates the non-metals from the metals. And on the zigzag border, we have the metalloids. Today's lecture will focus on the nonmetals as we discuss the formation of cations. Welcome to Mrs. De Castro's chemistry class. Today we will be discussing the formation of anions. So anions are your negatively charged ions, and they are negatively charged because their number of electrons is greater than their number of protons. So how are they formed? They are formed when non-metal atoms gain electrons. And the non-metal atoms gain electrons to comply with the octet rule. And why do they have to gain electrons? Because it's easier for them to gain than to lose their valence electrons. And that is usually because the number of the valence electrons is a lot more. All right, so let's take chlorine as an example. So chlorine, 1735, it has 17 protons, 17 electrons, and 18 neutrons. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. So chlorine has 7 valence electrons. With 7 valence electrons, in order for it to attain the stable configuration of 8 electrons in the outermost shell, which is easier for chlorine to do? Is it easier for it to lose all 7 or to just gain 1? So it's easier for it to just gain 1, and so we will have the formation of your chlorine anion. And how does that happen? Let's take a look. All right, chlorine, 1735. So if we were to draw the chlorine atom, we would have our nucleus with 17 protons, 18 neutrons, and based on our electronic configuration, we have 3 electron shells. Okay. The first shell has 2 electrons. The next shell has 8. Okay, so we have our 8 electrons here. And you notice that the outermost shell will have 7. Right? Okay, so we said for chlorine to be stable, it's easier for it to gain 1 electron, right? And so if we were to draw the chlorine ion, it will be like this. We still have our 3 electron shells, right? So we will have our 2 electrons in the first electron shell, our 8 in the second electron shell. We have our 7 electrons in the outermost shell, but now we said chlorine is going to gain 1 electron, and we will show that by way of an electron from another source. And since it has gained 1 electron, we will have here the chlorine ion represented this way. So this is your chlorine ion. All right, this is your chlorine atom. So what happened here? From 17 protons, it will still have 17 protons. This one has 18 neutrons. It will still have 18 neutrons. But now, this one has 17 electrons, whereas this one will now have 18 electrons. So if we look at the electronic configuration of your chlorine ion, it will be what? 1s2, 2s2, 2p6, 3s2, now it is a 3p6. And so your chlorine ion is now stable. Okay, so I will pause here and let us work on some other examples. All right, let's look at another example. Oxygen. So oxygen 816, that means it has 8 protons, 8 electrons, and 8 neutrons. Its electronic configuration is 1s2, 2s2, 2p4. So oxygen has 6 valence electrons. How will it become stable? It has to comply with the octet rule. And how will it do that? Notice, class, it's easier for oxygen to just gain 2 electrons rather than lose its 6 valence electrons. So by gaining 2 electrons, it will have 8 electrons in its outermost energy shell. Right, so if we were to draw the oxygen atom, right, this is your oxygen atom, it would have your nucleus with 8 protons, 8 neutrons, and then you have your 8 electrons in 2 electron shells, 2 electrons in the first energy shell, and then you will have your 6 electrons in the second shell. So if it gains the 2 electrons to become stable, then it will have, you still have your 2 electrons, but now notice it will have 8 electrons in the second shell, right? Let us put a different color here, right? And so you will now write it this way. It has a charge of 2 minus. This is your oxygen ion, right? And let us compare. Your atom has 8 protons. Your ion will still have 8 protons. Your atom has 8 neutrons. It will still have 8 neutrons. But now, how many electrons do you have in the outermost shell? You will have 10 electrons. So how did I get the charge of -2 for oxygen? So your 8 protons will give you a net charge of 8 times +1, which is 8. And your 10 electrons will give you a net charge of 10 times -1, which is -10. And so your oxygen ion has a charge of -2. Okay, so let us work on your worksheets now and look at other examples.